All right. Hello. Welcome to Best Practices for Amazon S3. My name is Rob Wilson. I'm a product manager on the Amazon S3 team, and I'm joined today by one of our great customers.
Hi, everyone. My name is James Brady. I'm the VP of Engineering at Teespring. And in a little while, I'm going to be coming back on stage and talking about how we didn't follow best practices, but are trying our best to now.
Excellent.
Okay.
Thanks, James.
See you soon.
Cool. Have no fear. James will be back. I have a little bit of a crowd participation question just to take a poll from the audience. Who's been using Amazon S3 for more than a year? Raise of hands. OK. 5 years? Keep them up. 10 years? Any 10-year veterans? Yep. We got some in the crowd. It's pretty cool to think of a service that's been around that long, really foundational to a lot of what you guys are doing with AWS. So hopefully we can cover a number of best practices today that you all can bring back to your own businesses and help you out. So that's myself and James here to guide you through the session today. And then through our agenda, as we go through these different items, I'll be mentioning a few best practices along the way. So some of you may be familiar with a lot of these features. For some of you, they might be net new. But we'll go through best practices along the way to give a little bit to everybody along the way. And then we'll be available for questions afterwards. So myself and James will be in the hallway if there's something we don't get to today that you'd like to discuss more. We also, throughout the course of the week, have a number of related breakout sessions. So there are topics like performance, cost optimization, and security that we'll go into a little bit today, but we won't be able to cover in as much depth as they will in specific sessions on those topics. So that's another thing that I'll leave these up on the board for a second, but if you're looking for other talks on Amazon S3, these are definitely a good place to start, and they're available in a lot of the different venues, so there might be something more convenient to your location depending on where you are on a particular day. So without further ado, let's start with an Amazon S3 overview, and then we'll go from there into some of the more in-depth topics. Up here, you see a number of the benefits of Amazon S3. So we'll really touch on a number of these today. But the one I want to mention in this slide is the scalability. So it's really exciting that you can get started with S3 just like that, just immediately start to put data to your bucket. And then you can grow to petabytes or more without thinking about hardware or capacity planning. It's just something we remove from your plate, and the storage scales as you do. And because of the many benefits we talk about with Amazon S3 and that you'll see today, we have customers from virtually every industry who use Amazon S3 to grow their businesses. Some examples of that would be Internet of Things, user-generated content, media content, and then data lakes. So I'm sure a number of you are using various use cases across the board here, maybe multiples of them, maybe you're really focused on one, but hopefully as we walk through the session today, you'll see something that you can bring back with you. And once you decide to move your data to the cloud, we've got 11 different ways to help you do that. I'll talk through a few of them in detail now, but there are also other sessions on these topics as well that you might find throughout the week. So for streaming data, you might want to use Kinesis and the different Kinesis services. One of the benefits of using these, and really a best practice when you think about using Amazon S3, is you might have smaller files, things like logs that are being sent over a period of time, and it might make sense to aggregate those into larger files. That can help with request costs. It can also make it just easier to manage your storage as you take some of those objects and aggregate them before they land in S3. Another option for physically transporting data to the cloud, if you don't have good network connectivity, or if it looks like it'll be faster just to actually ship the data to us, we've got Snowball, Snowball Edge, and Snowmobile as options for you. We've also got services for SFTP transfer. Then you've got things like data sync and transfer acceleration that can help you move data that much faster to and from the cloud. So we have different optimizations through both those paths to help you move your data faster. And now we'll jump into our storage classes. So I'm sure many of you are familiar with our different offerings, but really taking advantage of all the different storage offerings is how you can get the most out of Amazon S3 and really save on cost as your data changes, potentially over time. So on this slide, on the left, you see a visual representation of how the price of S3 standard has dropped over time. Since 2006, we've innovated on behalf of customers to make the storage simpler to use and then also more cost effective. The cost of S3 standard has actually dropped over 80% since we first launched in 2006. And then on the right side, you see that we continue to add storage classes over time. Over the past year, right around the past year, we've introduced two new storage classes that we'll go into a bit more detail in just a second: Intelligent Tiering and Glacier Deep Archive. both of which help you to rethink the way you manage storage in the cloud and offer up new opportunities and more convenience when you're thinking about managing your data in the cloud. So with the launch of intelligent tiering in Glacier Deep Archive, you now have 6 major storage class options when you're looking at storing your data in S3. As we start from the left side, I'm sure many of you are familiar with a pattern where you just start by putting data in Amazon S3 standard. Really a good general purpose storage class for active, frequently accessed data. You get milliseconds access. It's stored in 3 or more availability zones. And there's no minimum object size, no minimum storage duration. So really any data can be put to S3 standard. You don't really have to think about it again. But for a lot of customers, it's not a one-size-fits-all solution. And you can really get a lot from using our infrequent access and archive options as well. So in the middle of this slide, you see one-zone infrequent access and standard infrequent access. Both of those, as the name implies, are optimized for those infrequent access workloads. A good thumb rule to say, well, what's infrequent and what's not, is usually when you access the data about 1 time or less per month. So you can see from the pricing on the bottom there, if you have something stored in a standard infrequent access and you access it all 1 time per month at a 1 cent per gig retrieval fee, it's right around the same price as standard. So really, you're kind of indifferent between the two at that point. But anything less than accessing that data 1 time or less a month, then you should really think about those infrequent access tiers. A thing to think about when you're saying, well, standard infrequent access, one-zone infrequent access, what's really the trade-off there? It's the availability zones and how the data is stored. So when you have something like recreatable data or data that's less valuable to your business, maybe it's temporary for whatever reason, then storing it in a single availability zone and having less resiliency might not be an issue, and then you save 20% relative to the price of standard infrequent access. Going all the way to the right on this slide, you see Glacier and Glacier Deep Archive. You get a much lower price point for storage in those storage classes, but you're now switching to an asynchronous access pattern. So you want to think about, well, what data can I wait maybe minutes or hours to access? For a lot of your maybe compliance use cases where you're just holding on to data for 5, 10 years, you've got a requirement somewhere that tells you to hold on to it, Glacier, Glacier Deep Archive are going to give you a very cost-effective way to store that. And with Glacier, you have expedited retrievals. So you can get that data in 1 or 5 minutes when you really need it back more quickly. And then for a lot of customers, though, when they say, well, it's been a year, we need to pull back logs or billing data to really do a whole year-long 12-month analysis on what's happened over this course of time, and you need to pull back records from 12 months ago, then using something like our bulk retrieval option gives you the lowest price per gig to get that data back. So then when you're retrieving maybe terabytes or petabytes of data, it might make more sense to use that bulk retrieval tier, get it back in the course of hours, but it's more cost-effective to get the data back. Now, the one storage class I haven't mentioned here is intelligent tiering, which really gives you the best of that frequent and infrequent access tier. So here's just a visual of how intelligent tiering works. This is a storage class that you can lifecycle data to. You can also just put your data initially in intelligent tiering. And it's a storage class in itself, so you put data into it. And then the data moves between a frequent and an infrequent access tier, depending on how it's accessed. So one of the most exciting things about the storage class is that it's doing that at the object level. So let's say we put 100 objects into intelligent tiering. If 2 of those objects are read frequently, they're read every day, read every hour. The 98 objects that aren't accessed will still move to that infrequent tier after 30 days if they're not accessed. So now you're getting the lower price point of the infrequent tier. The 2 objects that are hotter, more active, more frequently used, they'll stay in the frequent tier. But now you have a blended price where you didn't have to do anything from a management standpoint. Your end customers don't know if you're using intelligent tiering or not. There's no retrieval fee for accessing the data. And now you've seen a lot of that data actually move to the infrequent tier. So we'll go to the next slide and talk a bit more how that works. The frequent tier is priced the same as S3 standard. And the infrequent tier is priced the same as standard infrequent access. So that's where the savings comes from, and it can be up to 40% as more and more of your data moves to the infrequent access tier. One thing to think about here is there is a monitoring fee in exchange for us doing that object level tiering. So because that monitoring fee is at an object level, what you'll want to think about when you say, well, should I move 100% of my data to intelligent tiering? It sounds like a pretty good deal. Is just think about object size and think about how long that data is going to stay around. It takes 30 days before we monitor the access and say, this data hasn't been touched in 30 days. Let's move it to the infrequent tier. So if you're only going to store the data for 30 or 35 days, you're really not going to take advantage of having that tiering occur. So you probably want to think of something that's stored for 60, 90 days or more for intelligent tiering to be a good fit. And then because that monitoring fee is at the object level, it's also important to think about the object size. So the larger your objects are, if they're megabyte, gigabyte size objects, when they move to the infrequent tier, you're getting the blended storage cost that's lower, and then your monitoring fee on a per object basis is smaller. So it'll factor in less to your overall storage bill. Whereas if you're moving a lot of objects that are kilobyte size to intelligent tiering, you might not see as much savings because more is being spent on the monitoring fee because of the smaller object size. So just something to consider. As we talk to customers, I think more and more of them are saying, how can I use more and more of intelligent tiering in my applications? Because of the benefits. So it's automatic savings for you, and you should really think, what data can I put in intelligent tiering right off the bat? Because you're going to get the most savings if you put the data there initially, rather than saying, OK, we want a lifecycle policy later on. So that's something to consider as you're looking at the storage class. Speaking of lifecycle policies, customers who might not think intelligent tiering is a good fit for them because of object size, because of how long they keep the data, might think that managing the storage classes themselves is a better fit. So we showed the storage portfolio earlier. And the other way to manage your storage is to use lifecycle policies. So if you have predictable access patterns, you can all probably picture it in your mind. Maybe the data is read a lot for the first 30 days, and then nobody ever accesses it again, but you've got to keep it for 10 years. If you've got storage that meets that need, lifecycle policies are a great fit because you have such predictability. You also might have data where you're not quite sure how predictable the data pattern is, or you're not even sure what the data access pattern is altogether. And that's where this feature comes in handy. So storage class analysis offers you a feature where you activate it at the bucket, prefix, or tag level. And what you're doing is saying how much data is retrieved relative to how much data is stored. And you're looking at that relative to object age. So on this visual I have right here, which is a clip from the console view, you see that between 60 and 90 days, so data that's that old, you see that there's more access happening than the data stored. That kind of one-to-one relationship that I talked about earlier. So here you're retrieving more data than you store. It's labeled as frequently accessed when the system looks at it. So it needs about 30, 35 days to analyze your data to really make a recommendation. But that data is frequently accessed. Probably a good fit to keep it in standard. You might also decide intelligent tiering depending on object size and so forth. But after that 90-day threshold, and we cross over it, you see there's so little access on the data relative to the data stored. That's where this system is recommending moving to the infrequent access storage classes. So somebody here could write a lifecycle policy saying that all data, 90 days or older, tier down to another storage class. So we'll see how that works right here. But here's an example of just how simple it is to set up a lifecycle policy, and then how simple it is to really understand how it works. So it's transitioning to another storage class just based on those object age rules. In this example, somebody's moving to standard infrequent access after 30 days, and then Glacier Deep Archive after 365 days. So you could picture here what might be happening in an application where once it moves to Glacier Deep Archive, you know that it's not eligible for an end user anymore. Nobody can go to your website, click on that object, and expect it instantly. You might then have a different process for someone to say, well, maybe they can view a thumbnail, but maybe there's a download button that kind of queues it up for later access. So when you think about integrating Glacier in, certainly something to think about. Another really powerful way to think about lifecycle policies is using them with tags. So there's a couple different things you can do here. I talked about the storage class analysis and how you could configure it at multiple different levels. You can also write your lifecycle policies to say, well, I've got a rule that's going to fit all my data in a bucket, or this bucket's used by so many different teams, so many different applications, or we just have different data segmented across different prefixes, where you want to write a more specific lifecycle policy. Now, one of the exciting ways to do that is to write it based on tags, because then those tags don't depend on what the object's named, don't depend on how it's organized in the bucket, but you're applying those tags and then writing a lifecycle policy. So I'll just give you an idea of how we've talked to some of our customers and really try to understand how they're managing their buckets. Some teams have hundreds of teams using particular buckets, maybe hundreds or thousands of different prefixes, and then you've got a lot of different data types. It can be tough to manage lifecycle policies with all those different combinations. Add that to the fact that some teams are going to want to move to standard infrequent access after 30 days. Other teams are going to want to do it at 90 days, 120 days, or whatever number they want to come up with. Glacier transition times might be different and so forth. So those customers, as we've been working with them, we've looked at, well, are there common patterns and common flows that might make sense? Where you could just say, there's about half of our data might be standard infrequent access after 30 days and Glacier after a year. If there's other data that's standard and frequent access after 60 days, Glacier after 2 years, you can picture all the different combinations there. You can assign different tags to just refer to what that flow looks like. And now, instead of writing potentially 400, 500 lifecycle rules to handle all those combinations, maybe you're writing 10, 20 tag rules, where you're just saying, this tag means that you move to standard and frequent access after 30 days and Glacier after a year. Great. Any data that meets that needs, tag it a certain way. So it really simplifies things for you from a management standpoint when you say, well, what's the best way to manage our data in a large bucket, for example, and what's the easiest way to use lifecycle policies. A feature we'll talk about later is batch operations to apply those tags. So potentially you want to apply tags in a large way to your existing objects. So that'll help you do that. And here's how simple it is to add tags to a lifecycle policy. So it's just as simple as adding that into the, in this case, we're just showing the XML. But when you go through the console view, you're just setting tags as a filter, and you can set multiple tags as part of a single filter. Another way to think about lifecycle policies is you might want to set a rule for the whole bucket, which is transition after a year, but then write more specific policies that transition objects earlier. So if the whole bucket policy is to transition after a year, but there's data sets that need a transition after 30 days, just tag those data sets with the exception, and then those will happen sooner, and everything else in the bucket will default to the year point. So you've got a few different options there. And then you can also use lifecycle policies to expire objects. So we'll talk about some examples of that later on where you might want to use it for an efficiency standpoint. But setting those lifecycle policies to expire data after you don't need it anymore is just one less thing that you have to manage on your own. And maybe it's 1 year, 2 years, whatever the number is, it'll just expire it in the background. So performance best practices, we talked about it a little bit with the synchronous and asynchronous access, but that's really just kind of thinking about storage classes overall. A few of the things I want to mention here are using the latest version of the SDK. So that's something that customers can do fairly simply depending on how your applications are set up. Upgrade to the newest SDK. You're going to get things like automatic retries, handling timeouts, and then parallelized upload and download behavior. So using multi-part uploads, using range gets, you can actually fan out large object retrievals and large object uploads across more of S3. So then it's going to happen that much faster. And it's going to really speed up overall application usage. And then on the bottom here, talking about a performance white paper that we put out fairly recently, but thinking about data that you want to cache. So if certain objects are read a lot by different applications, might make sense to use a service like Elasticache, CloudFront, Elemental Media Store might be a good fit to get their requests off of S3. So it might give you better latency, might give you improved throughput, and then you might lower your S3 requests because you're taking some of those more active objects and actually moving them closer to the application and getting it, removing that retrieval from S3. You can also think about scaling horizontally. So more threads and more connections to your data. And then transfer acceleration, which was a service I mentioned earlier. There's also a few other sessions this week on performance specifically. So I'll leave those numbers up there. But if you want to dive deeper into performance, think about object key naming. For most customers, you're not going to need to think about different key naming for performance. But for specific workloads or specific things like launches or where you expect to ramp up very quickly, you might want to think about that. And those sessions will go into more detail. So next I want to dive into security and some of the things we give you to control access to your data, some of the granular controls and some of the overall features and functionality. On this side, we'll do kind of an overall overview. Block public access is where I'll start. This is an absolute best practice for data that you want to be private, either within an account or explicit cross-account. But if you don't want public access to any data, think about setting this feature at the bucket or account level. If there's no reason for that data to be shared publicly, this is just another layer of protection. You might already have your policies and access control lists restricted to just the users in your account. But this prevents you from having a misconfiguration or other change that might actually open up access to other customers. Your buckets and objects are secure by default, but we give you other mechanisms to make them available. So the block public access kind of ends up being the umbrella that can block that public access if it's granted incorrectly for any reason. So we offer the ability to encrypt data by default at the bucket level. We offer encryption status in the S3 inventory report to then audit that and see if you're meeting compliance purposes and encrypting all your data. And then bucket permission checks and trusted advisor. So this will show you a list of all your buckets and then what access is being granted for those buckets. So whether a policy is public, whether the access control lists are public, it's an easy way to view all your buckets and actually kind of just see all regions aggregated in an easy way. So as we look here, this will be a recap for some, but new to others. I just wanted to reinforce that policies are really what we recommend customers use. Access control lists are available, but they don't offer the same flexibility, and they can be more difficult to update. So I'll talk through how that might work and why we might push you towards policies. So object access control lists, you can give someone read access to a particular object, or you can give them the ability to change the access control list. Bucket access control lists give someone the ability to read the object, so basically list the objects in a bucket, or write objects to that bucket. Now, you might want to give somebody read access to a particular prefix in your bucket, for example. So now you want to get more specific. The way you do that with access control lists is you'd have to give them read access to all the objects. What does that mean if you have to make an update? If you have to remove that access, you then have to update all of those access control lists. If you did that through a policy, though, read access, get object access is granted to this user for this prefix in my bucket, and that's something you can update very quickly to add it, and then very quickly to subtract it. So access control lists, really not our recommendation for the way to control access. You're going to get a lot more functionality through bucket policies in how many different operations you can spell out and how you can control it, and then it's much easier to update. So both on the user and bucket policy side. So with block public access, we'll talk through the 4 different settings right now. Importantly, for the account level setting, it applies to all your existing buckets and then all new buckets as well. So if you think that account is never going to have public data in it, enable block public access at the account level, and that's just going to assure on a moving forward basis when somebody creates a new bucket that it's going to fall under this control. And then there are 4 different settings, so we'll talk through those in a second. And then importantly, if you have block public access and you set it on all your accounts, all your buckets, then you say, well, everything's set up correctly. I want to make sure nobody changes it. Use AWS organizations and a service control policy to lock down the ability to change that block public access setting. Here are the 4 different settings you can do. The first one blocks new public access control lists. So if somebody tries to upload an object with a public access control list, granted, that put will be denied. So that's what that first setting does. The second one says, I might already have a lot of public access granted through my existing object access control list, so enable that setting to block access through that vehicle as well. The third one is blocking new bucket policies that grant public access. And the last one is blocking public access granted through existing bucket policies. So now you have 4 different controls. For a lot of customers, it's going to make sense to enable all of them. But depending on how you're using S3, it might make sense to enable some combination of them. The default encryption we talked about earlier, something you enable at the bucket level, ensures that all objects that are put to that bucket moving forward are going to be encrypted. If you specify encryption as part of the put request, that encryption will be used, the encryption specified in the put. But if you do not specify encryption or somebody's uploading objects as unencrypted and with no encryption specified, then the bucket default will apply to those objects. So this applies to new objects. If you want to encrypt your existing objects, we can go through and talk how you can do that with batch operations. So this next section, we'll talk about some tools to manage objects at scale. We've got a few different ones that we're going to dive into here. First is S3 inventory. So S3 inventory is an alternative to using the list API. When you get to millions or billions of objects in your bucket, it's not particularly efficient to list them 1,000 at a time and construct this list of all your objects. If you have very specific things, like maybe a small prefix in your bucket or something else where you want to list it and you want to know that quickly, there's still a need for list. But if you want to go ahead and list the entire bucket, much easier to use inventory. Inventory is delivered to you daily or weekly to a bucket of your choosing, prefix of your choosing. And then it shows you all this different metadata. So storage class, creation date, things like the replication status of the object, encryption status, and now the intelligent tiering access tier. So we talked about that storage class earlier and how it moves from frequent to infrequent tier. This is going to show you what tier any particular object is in. Then you can use this to audit objects to answer questions like, do I have unencrypted objects in my bucket? Which, speaking of, here's a simple query, and it shows you how easy that is. So you've got Athena, which is very good at querying objects in Amazon S3. I have an inventory report. I want to look through that and say, show me all the unencrypted storage in a particular inventory report. So then I get that list of objects, and then you'll see how we can then take action on those objects. So very simple to get up and running with this, and then you can customize the queries to answer whatever question you're looking to answer. You can then take that list, or another list that you might have of objects, and use something like batch operations to take action. This is a new feature that we launched within the past year. And it's really good at operating on objects at scale. So instead of you building a tool saying, well, I want to copy these objects, let me just keep calling the copy API. That's a lot of building a tool and managing a tool and then updating it to do something that's pretty undifferentiated. So batch operations, you have your list of objects. You tell us what operation to perform. So that can be things like changing an access control list, tagging objects, copying objects, restoring them from Glacier, or running Lambda functions. So you can do any of those operations. With the possibilities of Lambda, for those of you that are familiar with Lambda, now you can do a lot there. You can write your own custom code. We'll talk through some different examples there. And then batch operations does the work for you, gives you visibility on what objects are, what percentage is complete, what percentage is not, and you can see that along the way. And then there's a completion report saying all the work that batch operations did. Here's another visual of how it works. So we have the list, we have an operation specified, and then you've got that progress visibility. But let's look through that example that we talked about earlier. So I have an inventory report. I filter it with Athena. I find all the unencrypted objects in my bucket. So I turned on default encryption moving forward. I feel good about that, but I want to find all the unencrypted objects. Now I can copy those objects back to the same bucket. So what that does is, for an unversioned bucket, it'll just overwrite the key. And now you've specified an encrypted object, so it's going to overwrite that. And then for a version bucket, we'll talk about later on how to clean that up, but you'll be writing a new encrypted object, and then you can clean up the older versions with the policy we'll look at later on. And then in this case, if I was doing something for compliance purposes, kind of wanted to keep track of when I did this on a particular date, then the completion report's going to give you those details and give you a list of all the objects. When you use batch operations with Lambda, you can do a lot of pretty creative things. So these are just some ideas to get you started. But you can specify a list of S3 objects. That's baseline, what we talked about earlier. You can also use URL-encoded JSON to pass parameters along the way. So you might have a manifest full of these values, and you say, well, I want to do copy with a specific source and destination for every single key. Because I want to do some transform. I want to rename objects in my bucket. If you're just doing all the objects at once, it gives you pretty basic functionality. But if you want to do something custom on individual objects, you can use the manifest to give us that source and destination key, do something pretty creative there. And then you can also invoke general purpose Lambda functions. So if you ever want to test a Lambda function in bulk or do something else with Lambda and you just want to trigger it in bulk, you can use batch operations to do that. So you can pass pretty much any strings you want to pass into your Lambda function, and then it'll take that as an input as part of batch operations. And you can look through our documentation to see some examples of how the Lambda function works with that input. And then Lambda functions can be used with our machine learning services like recognition. So you could do image recognition on millions of objects in your bucket. You could do that through Lambda. You could also do things like copy with the parameters we talked about earlier, but that could also be custom tags, maybe custom encryption for different objects, and then running your own custom code. So certainly, it's up to you on what custom code you want to run, but build your own Lambda functions, run them on existing objects with batch operations. Really opens up a lot of different possibilities to you. And now, without further ado, I'll bring up James from Teespring. We'll talk about how they use Amazon S3.
Great. Cheers, Rob. OK. Hello again, everyone. So it's a pleasure and an honor to share a couple of stories about how we at Teespring use S3, and in particular, a couple of the features that Rob just explained we've been using for the last year or so to great effect. But first, to set some background context here, what is Teespring? So Teespring is the leading social commerce platform that allows anyone, anywhere, to design and sell physical goods. I'll go into what that means from a technical perspective in a little while. But just to kind of linger on this slide for a moment, what that really means for us is that we work with some of the top YouTubers, Twitch streamers, Instagram influencers, people like that. And we enable them to bring to a market a physical product, a T-shirt, a hoodie, a phone case, a sticker, a plushie toy, things of that nature, and then get them out to their fan base, get them out to their audience. So for the creator population, they are able to grow their brand, support themselves, because they make some money from it, obviously. And the fans get a real physical connection in the mail with these people that they look up to, with the creators. So to explain the kind of the flow of the business a little bit more, You can really simplify it down into three pieces. There's design, there's e-commerce, and there's manufacturing. So firstly, by design, what I mean here is that we have the creator population, YouTubers, for example, Twitch streamers, and they use a tool within Teespring called the launcher, which is a browser-based tool. And it's where they specify, I want to sell a mug with my face on it. And my face is this, and it goes here, and do that kind of layout work. And one of the things that the launcher tool does is it generates a bunch of assets, of images, in multiple different formats, and it has to get those into S3. So just a quick note about signed Amazon S3 links here, which we've been using for forever and super convenient for us. The reason that's important here is because the launcher is a browser-based tool. The creators aren't trusted people. They're just randoms on the internet. So we don't want to have a kind of public writable bucket. That would be definitely bad practice. And in fact, even the policies and the ACLs that Rob was just talking about aren't flexible enough here, because we want to very specifically allow for this person in this session to write to this object in this bucket. So it's very, very scoped down, and we can't really update policies fast enough. What signed URLs let us do is exactly that. We say to this user session, really, you now, using this token, effectively, have a way of writing to this place in the bucket. So that's how the assets get sent up from the launcher and then into S3. From S3, those images are used in multiple different places. So during the e-commerce experience, which is where the buyers are browsing around and hopefully buying stuff, we have generated these product previews. We call them mock-ups. And those mock-ups are basically a representation of what the buyer is going to get when they rip open their package in the mail. It's a sort of ghosted image of a T-shirt or of the mug or something like that. And then during the manufacturing stage, we have what we call print files, which are kind of machine-readable, normally very high-resolution images, which get fed into digital printers, die cutters, embroidery machines, things like that. And then from that point onwards, the products flow out to the fans. Now, the eagle-eyed amongst you will have noticed that the e-commerce and the manufacturing steps are actually kind of flipped here compared to a traditional business. So normally you make something, and then you sell it. For us, we do print on demand or just-in-time manufacturing for 99% of the things that we sell. And one consequence of that is that, well, I said on the previous slide that Teespring is all about allowing anyone, anywhere to bring a product to market. Combining that with the fact that we do just-in-time manufacturing means that we have a really large, a huge amount of data that we need to deal with inside of S3. When I say anyone, anywhere, what that means for us is there's no risk of launching a product on Teespring. You don't need to pay. You don't need many technical skills at all. What that means for us is that we have 7.5 million creators registered on the platform, and we have maybe 75 million designs. For each of those designs, there's maybe 10, 15, 20 different variants based on size and color and that kind of thing. So putting all that together, and we end up with billions of objects in a bucket, and we end up with petabytes of data. So what I'm not going to be talking about today is with 2020 hindsight, what would we do? Well, these are the things we would have done. I'm not going to cover these in much detail, but we would have put the objects into the right storage tier according to the information that Rob just shared. We would have tagged the objects up front. We would have given them meaningful names. We would have put them into folders or prefixes. Now, the fact I have this here should hopefully highlight the fact that we actually didn't do any of these things, unfortunately. That's okay. Like a bunch of you will be in the same position here. If we're building it from scratch, knowing the scale, we would have made some different decisions probably. There's almost certainly people in this room who are operating at much larger scale and can honestly do a better job of explaining how to do that than I can, so I'm going to swerve around that. What I am going to talk about, though, is, I mean, especially in a startup situation, which is what Teespring was and is, you never really have enough time to do things perfectly. You rarely have enough time to do things properly. You need to be doing things that don't scale. You need to be kind of cutting corners effectively. And for us at Teespring, what that meant was we had engineers just working flat out, desperately trying to keep up with the demand on the platform and trying to take advantage of the opportunity that was in front of us. So that's how we ended up in this slightly sticky situation. But what I'm going to be talking about then is how we use a couple of the features that Rob just talked about before to enable us not to fix yesterday's mistakes. I'm going to rephrase this into yesterday's compromises, because if we hadn't taken those kind of shortcuts in the early days, maybe the company wouldn't have survived if we were, too busy figuring out the perfect solution rather than going as quickly as we could do. So compromises rather than mistakes. And the two features I'm going to talk about are intelligent tiering and batch operations. So firstly, intelligent tiering. Okay, so I'm going to pose a problem here. We had several buckets containing billions of objects. All of those objects were in the standard storage class, which, if you remember, was on the leftmost end of the scale, the best performing but the most expensive. Now, for us, some of those objects were extremely important. They were used all the time, daily. And then, in contrast, some of those objects in the buckets hadn't been accessed since the day that they were created 7 years ago. But we were still paying, the kind of premium to keep them in the standard storage class. So, I mean, Rob kind of gave the game away a little bit here, but the answer is intelligent tiering for a really good approach to how to address this. And the end result of having put objects, we basically just put whole buckets worth of objects into intelligent tiering, and as a result saved around about, it was actually just under 20% on our storage cost. I can't emphasize enough how simple this was. It was almost zero effort. It was maybe like a day or two's work to figure out which buckets we could address, and then to do it, and then it kicked in, and then 30 days later, our storage cost dropped. It was insane. You have to look at this. It's so convenient. It's so low overhead. I guess it kind of cuts both ways. The fact it's so simple means that it's sort of one size fits all. It's not super customized. It's not really customizable at all. You decide where to apply it, which is why it's so easy, but also not as flexible as other systems such as batch operations. So again, I'm going to pose a question here. Okay, so we've got terabytes, petabytes, in fact, of unstructured data in your buckets. And by the way, that's spread across billions and billions of objects here. You think that many of those objects could be deleted or moved to Glacier or Glacier Deep Archive, but you don't have a way of reviewing every single object. You don't have a way of going through billions of objects and saying, oh yeah, this is a good one. Let's keep this in the bucket or to archive it. So the reason this is a better fit for batch operations is that in this particular case, the answer to that question, should I move it to Glacier? Should I keep it in this storage class or do something else with it? It depends on domain-specific information. It depends on the nature of the business itself. It isn't a kind of one-size-fits-all thing. So let me kind of explain how we use batch operations more specifically here. Okay, so we're going to start with some business logic, and by business logic, what I really mean here are just some rules. So let's say there's a creator on Teespring who hasn't signed in for 2 years. They haven't sold anything in 2 years. Nobody's even looked at their listings in 2 years. For us, we're very comfortable saying, you know what, this user's not active anymore. We are very comfortable moving their assets, moving those images that had on a few slides back. We're going to move those out to Glacier. Another example could be, we unfortunately have had problems with IP copyright infringement on Teespring. It's the user-generated content, so we encourage everyone in, but unfortunately there's some bad actors. And we take action against that, of course. So if we've suspended a listing because they've used a Nike logo or something like that, we definitely don't want to ever sell that because we're making ourselves liable. But neither do we want to delete it because we might have to keep it around for legal purposes later on. So those are just a couple of rules for where, based on kind of internal Teespring knowledge and domain-specific information, we might decide that, you know what, this object actually belongs in Glacier. So we've got the rules. We feed the data in from Redshift and from RDS. Those are the main databases that we use. And out pops a list, really, which takes the form of a manifest file. It's really just a CSV. It says, this is the name of the bucket. This is the name of the object. And in this case, what I'm trying to represent is, in the manifest files are all of the objects that fit the criteria of the business logic, right? So we'll be listing all the assets that belong to suspended listings or inactive creators for the two examples that I gave. And then from the manifest files, you can feed those into batch operations. And it's at this point that you specify the operation, and the operation is like I guess kind of like the verb, and the manifest file is the nouns that you want to apply it to. In our particular case, again, continuing on with the same example here, we've got a bunch of objects in a few different buckets here. What we did was tag them. We applied a tag to all of those objects, and then have a lifecycle rule to move those objects out to Glacier. So this is definitely a lot more effort, as you can probably tell, compared to the intelligent tiering, because we had to come up with the business rules, we had to feed the data in, we had to get the manifest files, we had to, it's a whole process. On the other hand, it's super. I mean, it's completely extensible, completely flexible, completely customizable. This was way more flexibility than we really needed, and we were literally just apply a tag to these objects. We weren't even using lambdas. So yeah, really, really, really flexible, way beyond the point that we needed. And you just have options. Like intelligent tiering is one size fits all, very easy, and batch operations is customizable and a bit more of an investment. Okay, so to wrap up here, ideally, you would add metadata to all the objects from day one. You would give them good names. You would give good prefixes. Maybe we would have even been generating the objects lazily. We wouldn't have created them all up front. We'd definitely be adding lifecycle policies and so on and so forth. But the main thing that I'm trying to get across here is, even if you don't do those things, and realistically, very few of us have the luxury of being able to do so from day one, there are tools within S3 that allow you to retroactively fix the compromises, not the mistakes, but the compromises that you made in last year or 5 years ago or whatever it was, pay down that tech debt and regain control of the data that you've got sitting in S3. Okay, I'm going to hand back over to Rob. Thanks, everyone.
Great. Thank you very much, James. That was awesome. So now we'll talk through data protection features. We've got another section on monitoring and visibility features. We'll go from there. So this first slide kind of is an overview of data protection features and what you've got available. So there's a few here that are bucket specific. So versioning and object lock work within a bucket on a particular object, for example. And then replication gives you the ability to then replicate the data to another bucket, whether it's in the same region or a different region. And it gives you some flexibility there on saying, well, I want to replicate this data. I want another copy of it. And it gives you some different controls on that. So replication, very similar to the lifecycle policies we talked about earlier. something where you set up a rule. You can say, I want to replicate everything that lands in this bucket. I want to replicate only things in a particular prefix. Or I only want to replicate the objects that are put to this bucket with a particular tag. So it gives you controls to decide what to replicate. A lot of customers replicate for compliance purposes. They need that second copy. Or because you want to get closer to end users. So if you mainly have users in 2 geographies in the world and you just want to set up replication between those 2 to get the data closer, you could do it for that reason as well. And with our recent launch of same region replication, you have the flexibility to replicate to another bucket in the same region or to a different region. Like I said, you have a lot of different flexibility on how you control your replication policies. So bucket, prefix, tag level. You can select the region, can be any second pair region you want. And then you have the flexibility to change the ownership and even do it across account. So for that case where you want another copy that's isolated in another account, different object owner, because you're worried about a bad actor. This is gold master copy. This is kind of the core of your business, and you just want to maintain a copy that's isolated and going to be there if you need it. Then the replication gives you all those controls within the policy itself to do that all automatically. And then you can also set the storage class. So for customers that do that second copy for compliance purposes, it might not make sense to be paying for standard on both copies of the data, especially if that other copy is just there for a just in case, for disaster recovery, for compliance purposes. So writing that data directly to a storage class like Glacier Deep Archive, now you have a much lower blended storage cost between the 2 regions. And just in the past few weeks, we launched replication time control. So for your most critical data sets, where you need to make sure that replica copy is there in a predictable period of time, let's say 15 minutes or less, we've designed a system that's going to replicate 99.99% of objects within that 15-minute window. We wrote a service level agreement for 3 nines of that. So you really have Amazon S3 standing behind the replication performance. And then you have all the metrics you need to monitor that replication performance. So let's take a look at those. 3 different metrics here that really give you a lot of visibility. These are replication latency. So how many seconds behind at a maximum is my source and destination region, or is the destination region relative to the source? And then 2 metrics on how deep the queue is. So how many objects are still waiting to be replicated? You could view that on an object basis or a bytes basis. And really the best practice here when you think about replication, and especially replication time control, is just deciding, well, maybe I do want to replicate 100% of my data, everything in the bucket, but maybe I only tag certain data to be part of replication time control. There is an additional fee for that predictable replication latency. So maybe you want to decide only a subset of your data needs that higher tier of replication. So something to consider and think about as you're setting up your replication rules. Another one to look at is bucket versioning. So this is something that's enabled at the bucket level. And the way it works is when you put a new object to the bucket, first object lands there, gets a version ID. And then when you overwrite that object or add additional objects with the same key name, you're adding a version ID. And what gets really interesting with versioning is kind of the different behavior you have in the bucket once you enable versioning. So if I just issue a GET request against this object, I'll get the most recent version, so whichever one was written most recently. But if you say GET object with a version specified, then you'll get that specific version of the object. So if you want version control, if you want to maintain that history of all the versions, you can get the one you want. You just have to specify the version. And then on the deletion side is why a lot of customers find this feature valuable, is that when you issue a deletion against the key, it puts a delete marker in place rather than removing your data. So you maintain the data in the bucket. There's now a delete marker added on top, so to speak. So when you do a GET on that object key, you get an error because there's a delete marker there. Essentially, to your end users or anyone else, that data is deleted. But to you, who's holding onto that data, you have the ability to roll that back. If you want to say, OK, that deletion was issued in error, or I changed my mind, or we need that data back, remove the delete marker, and now you've still got your data in the bucket. You also have the flexibility to delete specific versions of the object. So you can do that in a couple different ways. One of them is a delete request with a version specified. It'll remove the exact copy of the data you specified. Or, as we look at this next slide, you can set lifecycle policies. So this is the way that you could almost set up a little bit of kind of a delay on deletions before they actually take effect. So you can still roll that back. You can still undo a delete, so to speak, because that data is still in your bucket. So you issue a delete. The delete marker is in place. Now your previous object that was there is now a non-current version. And this lifecycle rule is based on the time at which something new was overwritten on top of it or when that delete marker was added. So in this case, the user writes a policy where they've now given themselves 7 days to undo a delete or roll that back before the object is actually permanently removed from S3. So when you've first heard about versioning in my description of it, all these overwrites happening potentially, it feels like a lot of storage is going to build up. But when you write a 7-day policy or whatever the number of days policy is, it's just cleaning up those older versions at the frequency that you desire. Another feature which really impacts objects at the object level is object lock. So a lot of you might be familiar with write once, read many, that terminology. So it gives you a few different options there. This was launched about a year ago as well. So you can set a compliant mode retention date on your object. Let's say I want to maintain this object for 7 years. Maybe I need to for compliance purposes. Set a retention date. It'll stamp that object 7 years from the day it's added to S3. It's a date on the object. No one can change it. Nobody can delete that object. Nobody can get rid of that until that period elapses. Compliant modes can be extended, but they cannot be shortened. So that is something that nobody can override. So it's very compliant, really meets a lot of compliance requirements around the world because of how strong it is. Governance mode is a more flexible form. So you put that retention date on an object, but somebody can delete if they have the proper permissions, or somebody can change that retention date, once again, if they have the proper permissions. So it's a question of choosing governance or compliance mode depending on what you're trying to accomplish. And then a legal hold is an indefinite period of time where you want to retain that object. So when the legal hold's in place, that object is protected for whatever duration the legal hold remains. But at any point in time, somebody with the right access can remove that legal hold. So it might be something where that hold's in place for 3 months, but then it's removed. Go ahead and remove the legal hold from those objects, and you can make a change. All this data is available in the S3 inventory reports we talked about earlier. And then similar to default encryption, you have a bucket level setting. So you can say every object that lands in this bucket, 3 years compliance mode enabled when it lands in the bucket. So now you're hands off, you put that policy in place, and then all new objects abide by that rule. And then our last section here, so monitoring and visibility. The reason we put this in the presentation, the reason we wanted to share this with you today is we commonly hear questions from customers, I wish I could see this with my storage, or I wish I had more visibility into this. Some of those questions are answered by some of these features which are already available, so I just want to make sure you're all aware of what you can do today. So this is not the most riveting example. I'll admit that right up front. This is probably like a demo bucket we set up. We added objects, and then it pretty much flatlines forever. You probably don't have a lot of buckets that meet this exact pattern. But what you get from your daily storage metrics, which is free of charge, is daily objects and object storage and object count by storage class. So when you're really trying to get a handle on what storage do we have, how are different buckets within my organization managing their storage, this is an easy snapshot view to just get started. Is it all in standard? OK, now to James's point, let's dig in and say maybe intelligent tiering is a better fit. Maybe some of these other storage classes are a better fit. A bucket with 100% data in standard might be a good candidate for storage class analysis and then taking follow-on actions. So this is just one of those ones to know you have available. It's easy in the console or CloudWatch or other mechanisms to access the data. Now this next one's where we see a lot more questions, where we say, have you tried request metrics? Are you aware that we have request metrics? Once again, something you can enable at the bucket, prefix, or tag level. Gives you a lot of flexibility to hone in on exactly the storage you want to learn about. But this is things like bytes uploaded, downloaded, latency, error rates across different prefixes, perhaps tagged objects. A cool case where we've talked to customers before is you might have a company that's expanding to a different geography. And you want to say, I want to see how the application's performing for the end users in that region. You could tag all the data associated with that, and then quickly see, how's the launch going? Well, you've got minute-by-minute metrics here on how much traffic is going to those particular objects. That might be your first indicator of how a launch is going. And then it might also be a case where you want to see what's the overall bucket, latency, traffic, and things like that compared to these tagged objects or compared to a particular prefix. So it allows you to dive into a little bit more detail. So you probably have some questions that could be answered just by turning on these metrics and getting a feel for how the storage is actually behaving. Now, building on that launch was a launch from a few months ago, which is viewing these request metrics with percentiles. So previously, min, max, average, that gives you some level of visibility. But that means a single outlier might just cause the graph to hop up here. And you start wondering to yourself, well, was that one data point where it really might not affect the user population? Or is that indicative of something else where maybe we need to think about a different design or something going on in the application that causes those outliers. So when you enable these different percentiles, you can customize whatever you want. If you want a P100, you can do that. But a lot of users find that P90s, P99, maybe 99.9, give you a better indication of how your end users are experiencing the service, what kind of performance they're seeing, and then also helps you think about your DevOps and other folks who are actually monitoring this. If you're going to set an alarm on a metric and have someone take action on it, let's make sure we're reducing the false alarms and getting to exactly the right metrics and exactly the right alarms that are going to mean something. So setting these percentiles on your request metrics, you can come up with the right set for you, but it's going to give you that much more visibility in your storage. So here's some summary slides. We've got AWS training and certification. Got a number of free digital courses, so this is something that's available to you. Go ahead if you want to grab pictures of that. Obviously, a lot of other resources available at reInvent as well. And then thank you all for attending today. So I appreciate your attention.